Good morning, students. Today we'll discuss the topic on semaphore. So we'll see what is semaphore. Semaphore, it is one of the synchronization tool. It is mainly used to solve a busy waiting issue. From where they took this concept, they took an example from the traffic light signal. So what is the help of traffic light signal? If there is no traffic light signal, what will happen? So it will lead to busy waiting. No one can move the vehicle in any other way. So from there, they took this particular concept. So semaphore, it is mainly used to solve the busy waiting problem. And how they are solving this, it is a hardware-based solution. It is mainly used to solve the critical session problem. And here they are using an integer variable called s. So that variable will mutually permit only one process to enter into the critical section. It will use all the resources, then it will come out. And the semaphore integer variable, it is working based on two atomic operation. One is wait and signal. So wait is nothing but like the meaning of atomic operation. I guess you would have already studied in database. It is either you do full operation or don't do anything. So same process only you're taking here. So the wait operation, either it will do fully or it will not do anything. So once it started till finishing, it will never do any other works. So that is the two process. One is wait and signal. So the wait operation, we'll see what is the further thing. And wait operation, it is used to test the semaphore variable. It is mainly used to decrement the value. So I'll explain in the code parts. We'll see what it is. If any value is negative value, this will lead to the indefinite waiting condition. And the signal part, it will be just if it will increment the semaphore value. And here there are two sections are there already you would have seen in the process synchronization. One is entry and exit section. Entry section will be controlled by wait operation and exit section will be controlled by the signal operation. So this is the data structure representation of semaphore. So the definition of wait will come as follows. So if you look at into this particular loop, wait of s will be checking the condition here while s value is less than 0 or any non-negative value, it will not allow any process to enter into the critical session operation. It lead to the indefinite loop. If this condition is false, what will happen? It will get into the while loop of body and it will decrement the s value. Whereas in other part of signal, only one operation will be there. There, just increment the integer value. S will be plus plus plus. So we'll see what it is. So for your understanding, I have just used a little bit changes here. So if you look at into this particular code, imagine the repeat operation will be started in the beginning. We'll be trying to use one mutex integer variable that is like a fuzzy logic zeros and ones. So when wait of mutex, it is called as an entry section. So we already given the condition in the previous slide, I guess you would have remembered, while s is less than or equal to 0, that is the intersection loop, it will lead to indefinite waiting. When this condition is false, the previous condition, if it is false, it will lead to the decrement operation. So then this process will enter into the critical section. Then once it finish all the operation, before leaving, it will give a signal of mutex variable. It shows that I finished all my operation. Then it will move into the exit section and remainder process can coming into the waiting state and it will be doing. So this is something like a cyclic operation. So if you look at into the example here, initially the mutex value will be 0 and it will lead to the indefinite wait. But in later stage, if you see, the mutex value will be incremented. Probably if you take this particular case, here s value is less than or equal to 0, it leads to indefinite loop. When any process want to enter into the loop, what it will happen? It will increment. So here 0 plus 1, if for example process P2 want to enter into the critical section, it will give a signal. So 0 plus 1, the value will be 1. Then what will happen? This condition will false. That process will be use a critical section and it will be do. So this how this critical section operation will be working. And this critical section, there are two most common kind of semaphores are available. One is called as a counting semaphore and other one is a binary semaphore. Counting semaphore, it is something like if there are n number of processes are there or multiple resources are there we'll be using the counting semaphore. For example, the traffic light, if there are 4 or 5 signals or some particular things are there, each signal depends on the load and other thing, the counting variable will be there. If the load is very low, that particular thing will get that particular side have to wait a lot of time. If the load is very high, something, that particular person will wait only few times. And the other one is a binary semaphore. It is like a fuzzy logic. It will have only two possible states, either 0 or 1. So if 1 it is the case, it will be locked. If 0 in the sense, it is called as unlocked. So two states will be there in this particular case. And here the two type the semaphore usage for this particular thing already I have discussed. So I want to show you a real-time example here. Probably you take this particular example. This is a hotel. Okay, so imagine this hotel is open at 9 o'clock or 10 o'clock. So the waiter, the security guard is giving a signal. He is telling hotel is open. So the people who are waiting outside will be permitted one by one. I guess you can see this particular diagram. So once that particular, like everybody went into the hotel and once all the chair is filled here, it will give a signal like a full. Okay, so restaurant is open, everybody occupied the particular stage, and the other bunch of people, they are coming and they are just go and asking the security guard, and he is giving a signal, please wait, because already the hotel is full, you have to be in waiting case. So he is giving a signal. So once this particular case, I guess you can take. Imagine in this particular case, previously all the 4 chairs was fully filled, and in this case, once the person is finished eating, he is giving a signal to the security. This signal operation is giving a signal, I have used my resources, so I have completed my operation, and he is giving a signal and leaving it. Meanwhile, the people who are waiting outside, he is approaching, he is telling, okay, 1 chair is free, you can go and use it. So this is how wait and signal operation is working. I guess everyone is clear with this. Thank you so much.